Welcome to ESE Doorstep. So we have discussed our friction chapter in which we have discussed some basic details of friction and we have also solved one numerical regarding that particular concept. Okay, in this particular lecture we will discuss this particular question and we will discuss how to solve this question and some important concepts regarding this particular concept. Okay, most important thing is that we will get some basic idea how to solve problems regarding friction. Okay, so let's start. In this particular question, we have to find out the value of force P which is required to move the block, and we have given coefficient of friction 0.25 and the weight of the block is 800 Newton. Okay, so in this particular question, we have to find out the value of P, force P, so that block can move. Important thing is that required to move, it is basically the condition of impending motion. In the previous class we have already discussed different cases of friction. That is, first case is rest, that is static. Second case is impending motion, that is just about to move or in the words of motion, and the third is dynamic. Okay, in this question we can apply the impending motion condition because in the condition given is that the condition given in this question is given that required to move, that is the motion is involved, required to move, basically motion involved है इस क्वेश्चन में, तो हम impending motion की कंडीशन इजीली अप्लाई कर सकते हैं. ओके, अब वैल्यू निकालना हमें P का, तो सबसे पहला स्टेप इंजीनियरिंग मैकेनिक्स में हमेशा होता है फ्री बॉडी डायग्राम बनाना. प्रीवियस लेक्चर्स में हम हमेशा डिस्कस करते हैं फ्री बॉडी डायग्राम कैसे बनाते हैं. ठीक है, तो पहला स्टेप हमारा होने वाला है फ्री बॉडी डायग्राम. ठीक है, तो सबसे पहले हम इसका फ्री बॉडी डायग्राम बनाने वाले हैं. ठीक है, तो सपोज ये हमारा कोई ब्लॉक है, दिस इज आवर ब्लॉक, this is our block, and this force P can be resolved in horizontal and vertical directions. Horizontal and vertical direction. The horizontal direction force will be P cos 35. P cos 35 will be the horizontal component of force P, and the vertical component will be P sin 35. Okay, and the weight of the block given is 800 Newton, and obviously it acts downward. Okay, it obviously acts downward, and the normal reaction will act upwards. So we can draw the normal reaction in this particular direction only, that is normal reaction N. So normal reaction and P sin 35 is acting upwards, and the weight obviously it acts downward. Okay, so we will just apply the equilibrium equation. Because the condition given is that required to move, so that it can move basically. So the condition will be obviously impending motion. When it exceeds the impending motion, then definitely the block will move. That's the basic concept here. Okay, so we will apply the equilibrium equation, and the first equilibrium equation that we are going to apply is that summation of forces along x direction equals to 0. Okay, summation of forces along the horizontal direction. X basically means the horizontal direction. Okay, we will just put the forces, the horizontal force P cos 35 and another horizontal force which will be acting here will be frictional forces. Obviously when two contacting surfaces are there, there will be two forces. One is the normal reaction force and one is the tangential force, that is friction force. Okay, so obviously the force, this P cos 35 will tend to move this block in the right direction obviously, and the friction force will act in the left direction, that is frictional force F. Obviously it opposes that particular motion, because friction is that particular force which will oppose the relative tendency of motion. Okay, so just we apply the equilibrium equation for the horizontal forces. The one force is P cos 35, okay, minus frictional force equals to 0. Okay, in this case we can apply the impending motion condition because the condition is required to move, just a motion condition, so we can apply impending motion. And we know that in the impending motion case the force acting will be equals to mu n. Most important thing is that this particular formula is only valid for the impending motion condition. And how we can get the idea of impending motion? It is given in the question that it is required to move, and it will definitely move after exceeding the impending motion condition. Okay, So we will apply this particular formula in this case. So in this case, P cos 35 will be equals to, we will directly put the value of frictional force mu n. We will directly apply the value of mu n. Okay, so coefficient of friction is already given 0.25. We have to find out the normal direction. For finding the normal direction, we will apply the equilibrium equations in the vertical direction, so that we can the value of normal direction, and we directly put the value of normal direction in this particular equation. Okay, obviously mu is already given to us, that is 0.25. Okay, we will apply the second equilibrium equation, that is summation of forces along vertical direction equals to 0. N and P sin 35 is acting upwards and the weight is obviously acting downwards. So N plus P sin 35 minus W, that is the weight of the block, is equals to 0. Okay, so N will be equals to W plus P sin 35 okay, W plus P sin 35. W's value is 800 Newton and P sin 35. Okay, P sin 35. Okay, and here is P cos 35 value is equals to mu n. We directly put this value of normal direction in this particular equation. Okay, we will put the value of normal direction in this particular equation, and we will get this is P cos 35 equals to mu values is 0.25, and the normal direction value is W plus W is basically 800 Newton plus P sin 35. From this particular equation we can easily get the value of P, because there is only one unknown here. We already know the cos 35.258 P sin, already unknown is P. So we can directly find out the value of P, and this particular value of P will be required to just move the block. So we get the basic idea of friction. So whenever you are solving the friction related problems, you should know when to apply the impending conditions. And the most important thing is that frictional force will be equals to mu n only when in the case of impending motion case. Okay, in the question it is given that it is required to move. It will move only after exceeding the impending motion condition, and after that it will come into a dynamic state. Before the impending condition, it will be in a rest, that is a static condition. So we will get some basic idea about the friction, and in the upcoming lectures we will discuss some more details about the frictions. Okay.